हेलो फ्रेंड्स, तोराना अकेडमी में आपका स्वागत है। हमने स्टार्ट की है 12th क्लास की केमिस्ट्री की एनसीईआरटी की वन शॉट सीरीज। स्टार्ट करते हैं यूनिट 3 इलेक्ट्रोकेमिस्ट्री। इलेक्ट्रोकेमिस्ट्री इज द स्टडी ऑफ प्रोडक्शन ऑफ इलेक्ट्रिसिटी फ्रॉम एनर्जी रिलीज ड्यूरिंग स्पॉन्टेनियस केमिकल रिएक्शंस एंड द यूज ऑफ इलेक्ट्रिकल एनर्जी to bring about non-spontaneous chemical transformations. The subject is of importance both or theoretical or practical considerations. A large number of metals, sodium hydroxide, chloride, fluoride, and many other chemicals are produced by electrochemical methods. Batteries and fuel cells used on a large scale in various instruments and can be energy efficient and less polluting. Therefore, and technologies that are eco-friendly, the transmission of sensory signals through cells to brain and vice versa have electrochemical origin. Electrochemistry is therefore a very vast and interdisciplinary subject. In this unit, we will cover only some of its important elementary aspects. Electrochemical cells in the class 11, unit 8. We had studied the construction and function of detail denial cell. This cell converts the chemical energy liberated during the redox reaction to electrical energy and has an electrical potential equal to 1.1 volt. When concentration of zinc and copper ions is unity 1 mole per dm, such as device is called a galvanic or a voltaic cell. If an external opposite potential is applied in the galvanic cell and increased slowly, we find that the reaction continues to take place till the opposing voltage reaction, the value 1.1 volt. Now, when the reaction stops altogether and no current flows through the cell, any further increase in the external potential again starts the reaction, but in the opposite direction. It now functions as an electrolytic cell, a device for using high electrical energy to carry non-spontaneous chemical reactions. Both types of cells are chemical both types of cells are quite important, and we shall study some of their salient features in the following pages. As mentioned earlier, class 11, unit 8, a galvanic cell is an electrochemical cell that converts the chemical energy of a spontaneous redox reaction into electrical energy. In this device, the Gibbs energy of the spontaneous redox reaction is converted into electrical work, which may be used for running a motor or other electrical gadgets like heater, fan, geyser, etc. Denial cell discussed earlier is one of such cell in which the following redox reaction occurs. Zinc plus copper then gives zinc plus copper. And this reaction is a combination of two half reactions whose addition gives the overall cell reaction. Copper to dipositive plus 2 electrons then gives copper. Zinc then gives zinc dipositive plus 2 electrons. Reduction half reaction, oxidation half reaction. These reactions occur in two different portions of the denial cell. The reduction half reaction occurs on the copper electrode, while the oxidation half reaction occurs on the zinc electrode. These two portions of the cell are also called half cells and redox couples. The copper electrode may be called the reduction half cell and zinc electrode the oxidation half cell. We can construct innumerable number of galvanic cells on the pattern of denial cell by taking combinations of different half cells. Each half cell consists of a metallic electrode dipped into the electrolyte. The two half cells are connected by a metallic wire through a voltmeter, and which externally the electrolytes of the two half cells are connected internally through a salt bridge as shown in figure 3.1. Sometimes both the electrodes dip in the same electrolyte solution, and in such cases as we do not require a salt bridge, and at each electrode electrolyte interface there is a tendency of metal ions from the solution to deposit on the metal electrode, trying to make it positively charged. At the same time, metal atoms of the electrode have a tendency to go into the solution as ions and leave behind the electrons at the electrode, trying to make it negatively charged. At equilibrium, there is a separation of charges, and depending on the tendencies of the two opposing reactions, the electrode may be positively and negatively charged. With respect to the solution, the potential difference develops between the electrode and the electrolyte, which is called electrode potential. When the concentrations of all the species involved involved electrolyte potential, according to IUPAC convention, standard reduction potential, also called standard electrode potential. In a galvanic cell, the half cell in which oxidation takes place is called anode. Half cell in which reduction takes place is called a cathode, and it has a positive potential with respect to the solution. Thus, exists a potential difference between the two electrodes, as soon as the switch is in the on position on the electrons flow from negative electrode to positive electrode. The direction of current flow is opposite to that of electron flow. The potential difference between the two electrodes of a galvanic cell is called the potential, and is measured in volts. The cell potential is the a difference between the electrode potential reduction potential of the cathode and anode. It is called the cell electromotive force of the cell when no current is drawn through the cell. Now, it is now an accepted convention that we keep the anode on the left and the cathode on the right. While representing the galvanic cell, the galvanic cell is generally represented by putting the virtual line between metal and electrolytic solution, and putting the double vertical line between the two electrolytes connected by a salt bridge. Under this convention, the EMF of the cell is positive and is given by the potential of the half cell of the hand side minus the potential of the half cell on the left hand side. E cell is equal to E right minus E left. This is illustrated by the following example: cells reaction copper plus silver is equal to copper plus 2 times silver. Half cell reaction cathode anode reduction oxidation. It can be seen that the sum of 3.5 3.6 leads to overall reaction 3.4 in the cell, that silver electrode acts as the cathode and copper electrode acts as the anode. The cell can be represented as we have E right E left is equal to E right minus E left. The potential of individual half cell cannot be measured. We can measure only the difference between the two half cell potential that gives the EMF of the cell. If arbitrarily you choose the potential of done one electrode half cell, then that of the other can be determined with respect called our standard hydrogen electrode, represented by is assigned a zero potential at all temperatures corresponding to the reaction. The standard hydrogen electrode consists of a platinum electrode coated with platinum black. The electrode is dipped in the acidic solution, and pure hydrogen gas is doubled throughout it. The concentration of both the reduced and oxidized forms of hydrogen is maintained at unity. This implies that the pressure of hydrogen gas is 1 bar and concentration of hydrogen ion in the solution is 1 molar. At 298 Kelvin, the EMF of the cell. Standard hydrogen electrode 2-second half cell constructed by taking standard hydrogen electrode as a reference half cell and the other half cell as cathode gives the reduction potential on the other half cell at the concentration of the oxidized and the reduced forms of the species in the right hand side and half cell are unity, then the cell potential is equal to standard electrode potential in not of the given half cell. The positive value of the standard electrode potential in the first case indicates that copper ions get reduced more easily than hydrogen ions. The reverse process cannot occur. That is hydrogen ions cannot oxidize copper. For alternatively, we can say that hydrogen gas can reduce copper under the standard oxidation conditions described above. This copper does not dissolve in HCl. In nitric acid, it is oxidized by nitrate ion and not by hydrogen ion. The negative value of the standard electrode potential in the second case indicates that hydrogen can be ions can oxidize zinc and zinc can be reduce hydrogen ions. Next equation. We have assumed in the previous sections that the connection concentration of the species involved and in the electrode reaction is unity. This need not be always true. Honors showed that for the electrode potential at any concentration measured with respect to a standard hydrogen electrode can be represented by, but concentration of solidium is taken as unity and we have not m plus m plus upon m has already been defined. R is the gas constant 8.314 joule per Kelvin per mole. F is Faraday constant 9645487 coulomb per mole. T is the temperature is Kelvin and Kelvin is the concentration of this species m. Table 3.1 standard electrode potential at 298 Kelvin. Equilibrium constant from next equation. Electrochemical cell and Gibbs energy of the reaction. Conductance of electrolytic solutions. Table 3.2 the values of conductivity of some selected materials at 298.515 Kelvin. Measurement of the conductivity of ionic solutions. Table 3.3 conductivity and molar conductivity of KCl solutions at 298.15 Kelvin. Variation of conductivity and molar conductivity with concentration. Figure 3.6 molar conductivity versus C1 half for acetic acid, weak electrolyte, and potassium chloride, strong electrolyte in aqueous solution. Table 3.4 limiting molar conductivity for some ions in water at 298 Kelvin. Electrolytic cells and electrolysis. Products of electrolysis. Primary batteries. Primary batteries. The commercial dry cell consists of a graphic carbon cathode in a zinc container. The latter acts as a anode. Secondary batteries. Fuel cells. Corrosion. Hydrogen economy. The present main source of energy that is driving our economy is fossil fuels such as coal, oil, and gas. As more people on the planet aspire to uh, improve their standard of living, their energy requirement will increase. In fact, the per capita consumption of energy used as the measure of development, of course, it It is assumed that energy is used for productive purpose and not merely wasted. We are already aware that carbon dioxide produced by the combustion of fossil fuels is resulting in the greenhouse effect. This is leading to the rise in the temperature of the Earth's surface, causing polar ice to melt and ocean levels to rise. This will flood low-lying areas along the coast and some island nations such as Maldives face total submergence. In order to avoid such a catastrophe, and we need to limit our use of carbonaceous fuels. Hydrogen provides an ideal alternative as in its combustion results in water only. Hydrogen production must come from splitting water using solar energy. Therefore, hydrogen can be used as renewable and non-polluting source of energy. This is the vision of the hydrogen economy. Both the production of hydrogen by electrolysis of water and hydrogen combustion is the fuel in the fuel cell will be important in the near future, and both these technologies are based on electrochemical principles. Summary: an electrochemical cell consists of two metallic electrodes dipping an electrolytic solution. Thus, the important component of the electrochemical cell is the ionic conductor, and electrochemical cells are of two types and galvanic cell. The chemical energy of the spontaneous redox reaction is converted into electrical work, whereas in an electrolytic cell, electrical energy is used to carry out a non-spontaneous redox reaction. The standard electrode potential for any electrode dipping in an appropriate solution is defined with respect to standard electron potential by half hydrogen electrode taken as zero. The standard potential of the cell can be obtained by taking the difference of the standard potential of cathode and anode. The standard potential of the cell are related to standard Gibbs energy and equilibrium constant. Now the reaction taking place in the cell, the concentration depends on of the potential of the electrodes, and the cells are given by Nernst equation. The conductivity of K of an electrolytic solution depends on the concentration of the electrolytic nature of the solvent and temperature. Molar conductivity and M is the defined as X K by C, where C is the concentration of conductivity increases decreases, but molar conductivity increases within decrease in concentration. It increases slowly with the decrease in concentration for strong electrolytes, while the increase is very steep for weak electrolytes, and very dilute solutions. Colorage has found that molar conductivity at infinite dilution for an electrolyte is sum of the contribution of the molar conductivity of the ions in which it dissociates. It is known as law of independent migration of ions and has many applications. Ions conduct electricity through the solution, but oxidation and reduction of the ions take place at the electrode in the electrochemical cell. Batteries and fuel cells are very useful forms of galvanic cell. Corrosion of metals is essentially an electrochemical phenomena. Electrochemical principles are relevant to the hydrogen economy. इलेक्ट्रोकेमिस्ट्री का ये था समरी। हमने स्टार्ट किया इलेक्ट्रोकेमिस्ट्री, जो कि हमारा 12th का क्लास का यूनिट 3 से यहाँ पर हम इलेक्ट्रोकेमिस्ट्री को ख़त्म करते हैं, जो कि हमने बहुत ज़्यादा शॉर्ट में कवर अप किया है। ये बहुत ज़्यादा बेनिफिशियल होगा आपके रिवीजन में भी। प्लीज़ इस वीडियो को ज़्यादा से ज़्यादा शेयर कीजिएगा। इलेक्ट्रोकेमिस्ट्री में हमने पहले से देखा गैल्वेनिक सेल्स, उसके बाद मेजरमेंट ऑफ इलेक्ट्रोड पोटेंशियल, उसके बाद नर्स्ट इक्वेशन, उसके बाद टेबल, उसके बाद इक्विलिब्रियम कांस्टेंट फ्रॉम नर्स्ट इक्वेशन, उसके बाद इलेक्ट्रोकेमिकल सेल्स एंड जिप्स एनर्जी ऑफ रिएक्शन, कंडक्टेंस ऑफ इलेक्ट्रोलाइटिक सॉल्यूशंस, उसके बाद हमने देखा मेजरमेंट ऑफ द कंडक्टिविटी ऑफ आयनिक सॉल्यूशंस, उसके बाद हमने देखा वेरिएशन ऑफ कंडक्टिविटी एंड मोलर कंडक्टिविटी विद कॉन्सेंट्रेशन। उसके बाद हमने देखा इलेक्ट्रोलाइटिक सेल्स एंड इलेक्ट्रोलाइसिस। उसके बाद हमने देखा प्रोडक्ट्स ऑफ इलेक्ट्रोलाइसिस। उसके बाद हमने देखा बैटरीज, प्राइमरी बैटरी, सेकेंडरी बैटरी, फ्यूल सेल्स, कोरोजन, एंड उसके बाद हमने देखा हाइड्रोजन इकोनॉमी एंड समरी। सो ये था इलेक्ट्रोकेमिस्ट्री का वन शॉट, जिसमें हमने बहुत ज़्यादा शॉर्ट में कवर अप किया इस चैप्टर को। सो प्लीज़ इस वीडियो को ज़्यादा से ज़्यादा शेयर कीजिएगा और अपने फ्रेंड्स तक ज़रूर पहुँचाइएगा इस वीडियो को, जिससे आपको भी बेनिफिशियल होगा और उनको भी रिवीजन में बहुत ज़्यादा बेनिफिशियल होगा। प्लीज़ लाइक, शेयर एंड सब्सक्राइब। थैंक यू सो मच फॉर वॉचिंग।